All right, hello, ladies and gentlemen. Welcome today to our lesson. Today we're going to be talking about some factoring by grouping. So, in our last video, we talked about greatest common factor and we talked about difference of squares. We also talked about some four, I think I mistakenly called them steps that we are going to use when we factor. I would like to change that, if I did say that, and change these to checks. So the way this works, I'm going to put a big line here. The way this works, similar to the last video, we have GCF that we're going to do first. We want to see if whatever polynomial we're looking at, if there's something that all the terms share that we can pull out in front. And then once we've done that, we want to reevaluate it, see if there's more that we can pull out. If there's not, then we're going to move below the line and we're going to look for difference of squares. Wow, that's all one word, difference of squares. And then we're going to look for difference of squares as our second step. Also, if there are two terms in our polynomial, that's like our hint to let us know that we can do a difference of squares. Now, we can't always do a difference of squares if there's two terms. If you don't know the rules, go ahead and check out the last video. But if there are two terms, that gives us a hint that we can either do nothing with it or do a difference of squares, at least as far as we know. So the next step is the backwards FOIL, layoff as we've been calling it. And this is the third thing we're going to look at. It's also has three terms. So when we have a three-termed polynomial, you know that we're looking at a kind of a backwards FOIL situation. And then lastly, what we're going to talk about today, factoring by grouping, is our last step, our fourth step that we're going to look at. And you guessed it, we're going to look at to do grouping when there are four terms. And not every four-term polynomial is going to be able to be factored by grouping. All the ones that I give you will be able to. I'm not going to try and trick you that way. But yeah, we'll move right into some examples. So our first example that we want to do, we want to factor x cubed plus 4x squared plus 2x plus 8. So this polynomial, we look at it, we go through our checks. I'm just going to write them really small up here. We have GCF, difference of squares, we have layoff, okay, and then we have grouping, which I'll just put group. Okay, so we look at this polynomial, trying to factor it. The first thing we look for is a greatest common factor that we can pull out of all these terms. Well, if we started with the x's, we would see that not every term has an x. All of these three do, but then this last term, our constant, does not have one. So we know that we can't pull out any x's. Now, if we look at our coefficients, we see that we have a bunch of even numbers, which is cool, except for our leading term here. If we were to do a greatest common factor between these four numbers, it would just be 1. And pulling out a 1, like we talked about in the last video, doesn't help us. So there's nothing we can pull out greatest common factor. So then, like I said, we go under our line now, our little line that we had just a second ago. And now we look, based on the number of terms that we have, at what strategy to do. So we have 4 terms. We're going to look to do grouping, which makes sense because that's what we're working on today. So the way that we do grouping, it's also, Mr. Gumke also jokingly calls it Spock. So the Spock symbol in Star Trek, he has, 4 fingers he holds up and then he splits them 2 and 2. Well, we're going to do a very similar thing here. We're going to look at our first 2 terms separate from our second 2 terms. It's like we have like a great dividing wall here with this plus sign, but we don't want to forget that that plus sign is there, so I put it down here, right? So what we're going to do now that we're looking at our 2 terms separately, the first thing we're going to do is look at the left side. We're going to look at x cubed plus 4x squared. Now we want a greatest common factor, these 2 terms. We can look and see that both terms have an x squared in them, so we can pull out an x squared. And then what's left over, our filling or our guts, if you want to call it that, we're going to divide our x squared into x cubed, which leaves us with an x, and then we're going to divide our x squared into 4x squared, which leaves us with a positive 4. Now, this positive sign drops right down with us, and now we're going to look at the right side of our equation. We're going to try and do a greatest common factor of that guy. So we're going to have 2x plus 8. If we look at our x's, we can't pull anything out there, so what we're going to do is we're going to look to pull out something from our coefficients. We see that both of these are even, so we know immediately we can pull out a 2, and in this case, that's all we can pull out. So if we do 2x divided by 2, leaves us with an x, and if we do 2x plus 8, that leaves us with a positive 4. So what we have now is 2 terms. So we've taken our 4 terms and we've greatest common factored them, and now we have 2 terms. Now we have 3 terms in here, but really this is like one. This is one multiplication here, so this is one term, and then we have a plus, and then we have another multiplication, so this is one term, at least as far as we're concerned. And if you want to go back to the original, it's like we put these in parentheses and made this one term and this one term. So now we have two terms, okay? So now what we want to do is we want to look at both of these terms and see what they have in common. So if I look at, so I'm looking at this whole multiplication. I could distribute this and shoot the arrows, but what would that really do for us? It would put us right back to here, and we didn't know how to factor it when we were here. So we don't want to distribute. We don't want to shoot those arrows. Don't do that. We want to leave it just like this. And so what we're looking for is something that both of these terms have in common. Now, if I were to read this out to you, you could probably tell me what they have in common. X squared times the quantity x plus 4. And then we have 2 times the quantity x plus 4. So even just in saying it, in both terms I said times the quantity x plus 4. So I know, even just, speaking math, which for some of you is hard and that's okay, but we know that this x plus 4 is what's common in both of these terms. So we're going to do a greatest common factor. So from the top, to get to this first step, we did a greatest common factor. And now, from here to get to our answer, which will be right down here, we're going to do another greatest common factor, right? So, greatest common factor, we're pulling out an x plus 4. Just like when we pulled out an x squared, we put that in front. Just like when we pulled out a 2, we put that in front. We're pulling out an x4, or x plus 4, so we want to put that in front. We want to make sure to keep it in parentheses. And I'll explain why in a second when we get the rest of our answer. So now our guts is what's left over when we divide by x plus 4. So we have an x squared, and we have a positive 2x. So this would actually be our answer. This would be the factored form of this original big gross polynomial that we didn't know what to do with. Now, I said I'd explain why we want to leave this in parentheses. The reason that is because when this is in parentheses, if we were to multiply it back together, we'd have to shoot our arrows, right? We'd have to do something like this. And so if we were to do that, which we won't do, but if we were to do it, it would give us this back, this x cubed plus 4x squared plus 2x plus 8. But if we took off our parentheses, so let me do some erasing. I got a lot of lines here, right? Okay. There we go. Okay, so I got x plus 4. I know it's a little gross now, but we have x plus 4 times x squared plus 2. So if we didn't have these parentheses, let's say we just took them off. What this is telling me, because these parentheses are gone, is telling me that there's an x out here that's all on its lonesome, plus 4 times the quantity x squared plus 2. So what this is telling me without the parentheses is that I'm going to just distribute in this 4. But like we just said, what we actually need to do if we wanted to get back to our original answer is distribute in the x as well. So that's why it's important to keep these parentheses when we pull out a term like this. Otherwise, your answer will technically be incorrect. So, got, I think, 3 more examples for you guys. They'll get a little more difficult, but mostly this video is just so you guys can kind of get, oh, I don't want to erase that. Mostly this video is just so you guys can kind of get the hang of the procedure. So, our next example we want to do is going to be x cubed minus 3x squared plus 4x minus 12. So, same thing we're going to do we did last time. I'm going to bring down this dividing wall, leave that plus sign because we want to make sure we know this is a plus sign. If it was a minus sign, we'd do something a little different with our grouping, but we're not going to cover that, so you guys don't really have to worry about it. So, just like last time, we divided this into like 2 parts. So we're going to look at these 2 terms and do a greatest common factor. So I look at my x terms, and I see that I can pull out an x squared. And then I look at my coefficients. I have 1 and negative 3. Well, they don't share a greatest common factor other than 1, which, like we said, pulling out a 1 doesn't help us. So now this is our x squared is all we can pull out. So when we divide x cubed by x squared, we get an x. And then when we do negative 3x squared by x squared, we just get a negative 3. So now our plus sign drops down. Now we're going to look at this term. So we look at our x's first, like we like to do. Both terms don't have x's. We can't pull out any x. Now we look at our coefficients. Okay, so we have a 4 and a 12. Now I know from experience that the greatest common factor of 4 and 12 happens to be 4. So I'm going to divide 4x by 4, gives me x, and then I'm going to divide negative 12 by x, or by 4, excuse me, negative 12 by 4, and that's going to give me minus 3, or negative 3. So, an important part to this step that I didn't mention last time, once you've done your first greatest common factor, once we've gone from our original problem here, we've gone down and we've done 1 greatest common factor. If you don't have 2 binomials that match, so like Here we have our binomial that's x minus 3, and here we have our binomial that's x minus 3. This is what we're going to end up pulling out at the end. If you don't have two of these that match, there's two possibilities. Either one, you did some bad division. So say maybe I flipped my sign and I had x plus 3 instead of x minus 3, and then I still had my x minus 3 over here. I would want to go back, because these are different, I'd want to go back and double check my greatest common factor. I guess there's three possibilities. So the first possibility is that you did some bad dividing. The second possibility is that maybe you didn't pull out everything you could. So say that with this 4x minus 12, say I had only pulled out a 2 to start. I'd be left with 2x minus 6. Well, these don't match, but I can still pull another 2 out of here, which eventually we'd get to the same thing that we have up here by just pulling out the 4 originally. So our first mistake is, or our first thing if they don't match that we're looking for, is to see if we did some funky dividing. The second thing we're looking for is to see if we can pull out more common factors from what's in here. Well, in either of these. The third thing is that maybe it's just not factorable by grouping. But for the ones that I give you guys, if it has 4 terms, it will be factorable by grouping, so don't freak out. So for you guys, that means that if these are not matching, you did something wrong along the way. Okay, so now we're going to look at these two terms. Moving right along, we're going to look at these two terms, and we're going to see what they have in common. Like I said before, they both have an x minus 3. If I were to read it out again, I could hear that they shared that. So I'd read it as x squared times the quantity, x minus 3, plus 4 times the quantity, x minus 3. So again, you could hear me say times the quantity, x minus 3 in both of these. That means that that's my common factor that these both share. And then again, our filler, or what's left to put into our parentheses, is what's left. So this x squared and this positive 4. So that's all for this one. Again, parentheses are important. If you wanted to ever check your answer on these, you could distribute, like I talked about on the last one. I don't ever expect you guys to do that, but if you wanted to be really thorough, make sure your answer was 100% correct, you could absolutely do that. All right, so our next one, we're going to do, let's see, yeah, that's what I wanted to do next. So let's go 4x cubed plus 12x squared plus 3x plus 1. So this one's a little different. I'll explain why as we get into it. But first things first, and I actually forgot to do this on the last one. Don't forget to do this. You want to look for a greatest common factor to pull out of all of these terms. Now I automatically know if one of my terms is 1, that there's nothing that all of these share that is going to be greater than 1. So we're good to go. No greatest common factor. Then we look at our next step. We look at our 3 things here. We know that we have 4 terms, okay? X cubed, x squared, x are constant. We have 4 terms, so we know that we're going to look at doing this by grouping. First step, split this right down the middle. Make sure I keep that plus sign there. And now we're going to look for a greatest common factor between these two terms. I know that we can pull out a 4x squared, which leaves us with x plus 3. And then our plus sign is actually almost already in the right spot, but I'm going to drop it down and erase that one. Okay. And then I'll put it up here so that we remember that there was a plus there. So I divided it, the plus is now up here, and now that we're doing our greatest common factor, this plus is actually part of our greatest common factor. So now we're looking at this term. Well, what can we pull out? Well, it looks like I might have messed up. Oh, that's a 9? Wow, my handwriting is so bad. All right, so 3x plus 9. What can I pull out of both of these? A 3. I was going to try and pull a 3 out of 3x plus 1, and I was like, Lucas, that doesn't work. But Lucas is my first name. Please don't call me that. Stick with Mr. McGill. I'd appreciate it. Thank you. Anyway, moving right along. So we got 3 is our greatest common factor of 3x plus 9. So we can go x plus 3 again. And now I know that both of these match. And so that's what I'm going to look to pull out into the front of our final answer. So I have our x plus 3. Again, remember the parentheses, they are important. And then we have what's left over, 4x squared plus 3. There you go. So that's our third example. We're going to do one more, just one more. Yeah. I know I said we'd do 5, but I feel like, you guys might be starting to see the pattern if you're watching. So this last one will be a little different. Nothing too crazy. We're going to start with the 4x cubed again. We're going to have a positive, not a positive. We're going to have a negative, or we're going to subtract a 3x squared. Then we're going to have plus 16x. Oh, got a little fuzzy there. 16x and minus 12. So again, we look at this before we divide it, before we even divide it, we should look and see if each of these terms has something that we can pull out, if all of them have something in common. I know that they don't, which is why I skipped my step and started dividing it already. And I also skipped the step where we decided to do grouping because there's 4 terms. So you guys, please make sure every time you do those steps, I'm doing a video on grouping, so I know that this is going to be a grouping problem already, but make sure you guys mentally at least go through those steps when you see these, when you're asked to factor these. So we would do our division, our great division. Okay, we divide this into 2. We look at our left side. I know that we can pull out an x squared. Now you might think that you'd be able to pull out something from these, but they're both, they don't share any factors. The factors of 3, if I were to do factor trees real fast, are 1 and 3. The factors of 4 are 1, 4, 2, and 2. They don't share anything other than 1, which we talked about in the last video, and even in this video, doesn't help us. Pulling out a 1, we could do it forever, it doesn't change anything. So I know we can pull out an x squared by looking at our x terms. And then we're going to be left with a 4x minus 3. I started to do a plus, but needed to do a minus there. Okay, so now we still have this plus up here. It's going to drop down in the middle with us. Now we're going to look to pull out the greatest common factor of 16x and 12. We look at our x's. We see that both of our terms don't have x's, so we can't pull out an x, but greatest common factor of 4 and 16, or of 12 and 16 is 4. So that means that we're going to divide 16x by 4. It gives us 4x. And then we're going to divide negative 12 by positive 4. Gives us negative 3. We can see that we have 2 binomials that match each other. And so we can just move right into our answer. We're going to pull these great common factors out in front. So we have 4x minus 3 times what's left in the rest of our parentheses, x squared plus 4. The reason this one was a little different is because it had these subtractions here. So in class we did an example. If you guys missed it, I'm sorry, I'll explain it a little bit. So in class we did an example where instead of looking at these 2 and looking at these 2, we did a little hopscotch action. So we looked at our first term and our third term, and then we looked at our third term, or our second term and our fourth term together, okay? And we ended up getting the same answer. But for this problem, because these are subtractions, okay, or because there is subtraction in it, we cannot do it. We can't just flip terms around like we did in our other one. The reason we could do that in our other one is because we had all additions, and so it didn't really matter if we looked at our first and our second term and our third and our fourth, or if those were our pairs 1, 2, 3, 4, or if we did 1, 3, 2, 4. So, but this one, because there are these subtractions, it is important that we look at our first and second terms and our third and fourth terms, doing this and then this, and not doing any fancy looking at our 4x cubed and 16, and then looking at our 3x squared and 12. We just can't do that on this guy. It wouldn't work out. At least, I don't think so. If you want to try it, go for it. Prove me wrong. That's fine. But I'm going to give you guys the caution sign here not to do that. So, because this way will always work. If you do it the other way, there's some cases where it will, some cases where it won't. So if you want to stay safe, just break it up 1, 2, 3, 4. There you go. So that's all I have for you guys. If you have any questions, you can comment on the video if you'd like. You can ask me in class. Yeah, I'll see you guys tomorrow. Have a wonderful day, and I will talk to you soon.